Hello, I'm Anton Smith, Director of Product Management at Spectro, and today I'm here to talk to you about our latest release, hot off the press, Palette 4.4. Palette 4.4 has a heavy focus on security and management at the edge. So today we're going to be talking about trusted boot and full disk encryption, as well as local UI enhancements. The first topic is trusted boot and FDE, or full disk encryption. And both of these are industry terms, and one of them is a bit more recent than the other. Full disk encryption has been around for a while, and I'm sure that you recognize the term, which is all about the encryption of sensitive data. But the way that full disk encryption is implemented matters, as we'll soon see, in particular at the edge. Now, trusted boot is an exciting new method to enable this in a way that is secure yet easy to operate. We'll get into that in a minute. Now, I'd like to start talking about trusted boot and full disk encryption by taking a look at a recent survey that we've run called the Spectro 2024 State of Production Kubernetes Report. Now, at Spectro, we've always had a very heavy focus on security, including but definitely not limited to use cases such as Kubernetes as a service, with our ability to enable automated regular security scans across 1,000, 10,000 or more clusters, or to schedule operating system patching and updates on a regular basis, protecting against security breaches. Now, our cluster profile capability, kind of like a blueprint, also ensures that customers can meet their needs with security by rolling out clusters in an industrialized manner, ensuring compliance guardrails and access controls are in place with standardized deployments at scale. Now, all of these capabilities that we already have are directly addressing the top concerns as evidenced by the survey. But what about edge? So we also asked questions about edge in particular. And while we see that we're meeting the needs for security overall with Palette with fantastic capabilities, there are some specific challenges that we have at edge. Compliance and security have dipped a little bit. It's still the number one concern for edge. And if we look closer, we see it's also balanced out by concerns about performing day two operations and avoiding costly field engineering visits. For edge, Spectro Cloud Palette is already meeting many of these needs. For compliance and security, thanks to our Senna architecture, which we've done together with Intel, we've supported immutable operating systems through our K8s technology, and we've supported ease of operationalization with EdgeForge. Now, keeping up to date with patches is also important, and our EdgeForge capability allows customers to easily customize their image and yet still be able to continuously and repeatedly roll out those images and those upgrades to entire fleets of devices. And we can't forget about our A/B upgrade technology, which enables devices to revert back to the last known good configuration in case there were any issues during upgrade. All of these are very important capabilities when we think about the kinds of conditions and locations that edge devices are subjected to or run into and the security implications involved. When it comes to day two operations and reducing field visits, all of these capabilities contribute. EdgeForge makes it easy to operationalize consistent upgrades, while Palette with cluster profiles and day two management capabilities directly addresses concerns about day two operations. These capabilities all directly contribute to reducing field technician visits, as well as reducing the level of knowledge needed when they do visit, because we embed so much of this capability into the platform itself. But Edge has some other challenges that we need to address as well. And so with 4.4, with our trusted boot capability, we're going to be addressing those challenges. Now, what are those challenges exactly? It's basically about physical security, either in warehousing, in shipping, in situ access directly at the final location where the devices are going to. There's a number of issues. There are third-party contractors, there are changes of shifts, changes of staff, poor background checks. There's always a pressure to fill staffing and get people in there. And there's also a lack of knowledge and a lack of capability at the sites. For example, they don't have IT expertise. So all of this contributes to a much more hostile security environment for those edge devices and the data on them, and that is primarily due to physical access. So how can we protect against that? The requirements here are quite simple. The top one is to protect the sensitive data on the devices, and that we can do with encryption. But because of the capability to physically get at the devices, we also need to prevent tampering. And that is altering the operating system or anything on the device so that they can perhaps inject another administrator user or something like that, and then use that to snoop on information in an ongoing basis, or simply lift off sensitive data directly off the device. In addition to that, we need simple lifecycle management. So no matter what we do with the solution, it has to be very simple to manage the entire lifecycle of every edge device in the fleet. And finally, this also needs to work in disconnected environments and without human intervention. In other words, in a similar way to when you open your laptop and you have encryption enabled, you enter a PIN and then it unlocks. That doesn't work for Edge because we need these devices to come back after a power cut or work without any humans around them at all. The way to meet those requirements is with a technology called Trusted Boot. Now, Trusted Boot is three things. It's Secure Boot, which is something that you're probably familiar with. This is about ensuring that the device will only load a certain trusted, signed piece of software. Secondly, it's Measured Boot. So Measured Boot is using a technology called TPM, or Trusted Platform Module, which is observing everything during the boot process and recording it securely into the TPM where it's impossible to tamper with it. And finally, it's encryption. Now, the encryption will only work providing that A, the secure boot process went as planned, and 2, that all of the measurements that were observed by the TPM are also met and that everything looks the way that it should. Now, that's how it works on the box, but the other thing that's really important is how to operationalize this, i.e. how to do the signatures, the signing of those images at an industrial scale. And that's where our Palette Edge Forge will come in, where utilizing our open source project K8s, the images are fully customizable just like normal, but we provide a very nice framework for customers to be able to bring their own keys or let us create the keys for them. Let's zoom in a little bit on this measurement technology. So first of all, the TPM receives measurements of every stage of the boot process as the device boots. That includes noticing whether or not it was running a signed image, something from the secure boot side of the solution. Based off all of those measurements at the end, the TPM is the device that has actually encrypted the keys that have been used to encrypt the data on the drives. So the TPM actually has kind of wrapped those keys in a protective layer, and it's the only thing that can decrypt that. I'd also need to add here that the TPM is physically secure itself. It's not possible to get into the chip and lift off any of these special keys. So what happens then if somebody steals the box? Well, they could take the box physically off the premises, but with Trusted Boot, they won't be able to put a USB stick or anything in there and load it because of Secure Boot. The box simply won't accept that. Even if it did, the measurements wouldn't look right, and so the TPM would never in the end release the encryption keys. And so that means that the person stole the device, but they basically have a brick. They can reinstall it completely and reset everything, but they'll never be able to get the sensitive data that was stored on the drive. Also, what happens if somebody steals the hard drive itself, like pulls it out of the box and walks away with it? Well, remember I told you that the TPM has the ability to decrypt the encryption key for the drive. So those people will have a disk that just has a whole bunch of encrypted data on it and they won't be able to get it off. Now, what happens if somebody tries to edit anything on the disk? Well, if they do that, they will corrupt the entire drive. We spoke about the nitty-gritties there of the encryption side, but now I want to talk about the operationalization aspect here. So number one, Edge Forge, easy operationalization. It's out-of-the-box trusted boot image generation and signatures with full customer control, the same as it's always been with Spectro Palette and K8s. Bring your own keys or let Edge Forge do it for you. Either way, you can manage tens of thousands of clusters with very simple day 0 to day 2 operations. Secondly, immutable upgrades. Our immutable technology also ensures it's very easy for you to verify the trust and the state of those operating system images, as well as being able to do secure upgrades. And finally, I need to say it again, all the capabilities we have in Palette for day 0 to day 2 operations, like granular security controls, guardrails with cluster profiles, security scans and observability, and more, are all contributing here to a very simple to use system. Now, if we look around a little bit at the marketplace and try to understand what's happening with competitors, we do see a mixture. Some of them, such as Talus, do secure and measured boot, but their Kubernetes management platform is not comparable to Pallet, for example, Omni. Others, like OpenShift, support only secure boot and not measured boot, which means that it's actually not very secure. The ability to tamper with those devices is quite simple. Additionally, they don't use an advanced technology that we're using called UKI, or Unified Kernel Image. Now, this is the way the industry is going. This is also backed by Intel, and Trusted Boot from Spectro Cloud utilizes this technology from day one. Zedida also has secure boot, but not measured boot. And then Kubernetes, Tanzu, Rafe, D2IQ, or Nutanix, they don't have either. Now, a recap on the Trusted Boot benefits. Tamper-proof systems with full encryption without compromise. Now, according to the requirements that we laid out earlier, this solution allows you to operate the edge devices in a headless manner. In other words, no human intervention is needed, either when they're booting initially or when they're restarting after, say, a power failure. There's no need for an external hardware key like a Yubico, which is another potential solution. There's no need for connectivity. They can run completely disconnected. They're secure and tamper-proof and offering full encryption of customer data. And finally, thanks to EdgeForge and Pallet itself, we have very simple lifecycle management. Wrapping it up for Trusted Boot and full disk encryption then, as we've seen, physical security is the real challenge there. Pallet Edge and Arsena architecture has the solution with Trusted Boot, full disk encryption, and the capability to operationalize all of that with EdgeForge, as well as taking advantage of our existing day 0 to day 2 operations with Pallet. Moving on, let's talk about local UI. So local UI with Pallet Edge is about addressing the challenge of poorly or disconnected clusters with minimal field competence. Let's take a look again at that survey result for Edge. Now, security, day 2 operations, and field visits were the top 3 concerns. Connected Pallet clusters already drastically improve this situation, but what about disconnected clusters? Let's start with the problem statement for local UI. Deploying and managing clusters in remote locations with poor or no network connectivity is challenging, expensive, and error-prone, and it requires highly skilled engineers. Now, just imagine that you have to send those engineers to all of those sites and perform a sequence of probably quite complex steps. If they get something wrong, they need to start again. Now, the solution here is to make that much simpler, and that's what we've done with our local UI capability. So platform engineers can plan and prepare installation materials or day 2 updates. They can then place those onto USB sticks, and they can give them to field technicians who then deliver those updates to the field. Now, when they get to the clusters in the field, they have an intuitive user interface that they're able to use to take in the content on the USB stick and apply it to the cluster. You can think of it as replacing the network connectivity with a USB stick in somebody's pocket. The magic that lets that happen, though, is that there's a very intuitive interface for the platform engineers, and then there's the local UI capability or the local administrator interface that is available on each one of those clusters. Let's take a look at the user journeys here. So at day 0, we have a platform engineer who can use Pallet to create a cluster definition, which is composed of various things, but basically they're designing the clusters and then they're preparing the content as well as the definition. So if you have a cluster definition and then you have the content, which is things like images, you can then create installation artifacts. And Pallet gives a very simple, easy to use interface to the platform engineer in order to do that. This creates basically a USB stick which can be used for installation of a cluster. They give the USB stick to a field technician who takes it to the site, plugs it into the piece of hardware, and they install it just like installing any operating system. Now, after that, they get given a network setup console, which all they need to do is get the networking working at the local site. And after they've done that, they can access the local UI. Once they access the local UI, they have a very simple, easy to follow interface to go through the steps of actually creating and verifying the cluster. And for day 2 operations, this whole process repeats. It's the same thing. They generate an artifact, they give it to a field technician, they go to the site, they use the local UI, and they perform the operations that they're supposed to. Now, the eagle-eyed among you will see that in the bottom right-hand corner, it says no YAML. Now, at no point here is this field technician ever presented with things like Kubernetes manifests. So local UI was actually introduced in Palette 4.3, but in Palette 4.4 we have continued to extend it with new diagnostics capabilities. So in particular connectivity checks, the field technician can run simple pings and traceroute commands directly from the local UI, as well as log downloads. Now that's important because, as you're aware, with Kubernetes there's a whole bunch of logs and things that can go wrong, and so now we have a very simple download button that the field technician can use when they're doing diagnostics. In addition to that, we allow customers to now embed their own links and content directly into the local UI. So imagine that a field technician goes to a site and the designers or the platform engineers want them to have a list of links that they can use without them needing to remember them or having them bookmarked individually on their laptops. Not only that, but they can actually embed their own web services in with the local UI. So if they wanted to add their own portal that is running there on those edge hosts, they can do so. Finally, but definitely not least, is the automated Kubernetes certificate management. Now, Kubernetes requires the certificates to be updated on a regular basis. By default, that's usually every year. Now imagine that for 10,000 sites that are disconnected. That would mean a field visit to every site. So now we've automated that. So that just happens automatically and completely reduces or removes the need for field visits at the site. So we can take a look at some screenshots here. This is the diagnostics logs, and this is the local UI itself. As you can see, it's a very simple interface. All they need to do is click on this download logs button that you see there, and they will receive the logs onto their laptop. After that, they can take them back to the central location if they need to, give them to platform engineers, and they can start to look at how things are going together. And here's the screen for the automated certificate updates. Again, very simple. They can actually do manual updates if they choose to, but the system will also continuously update status on this local UI to inform engineers when they're on site how long it is until the next automated renewal. Okay, so I hope that you've got a good feeling for these two major new deliverables in 4.4. Trusted boot with full disk encryption, as well as enhancements to our local UI capability. If you want to know more, join us on Slack. Every release always has far more than the headlines, so you can also check our release notes. Check out our production survey, which I mentioned before. It's a really fantastic read. Then if you want to see the local UI hands-on walkthrough, there's a link here, as well as a trusted boot walkthrough. And then finally, there's a Senna white paper that was published by ourselves and Intel, which is always a good read. And with that, I'd like to say thank you for today and hope to see you around.